This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video on surface area, we will be looking at some examples of how to calculate surface area of three-dimensional objects. So let's look at the total surface area first of a cone. To find this, we look at the area of the circle and the area of the orange sector here. So what we've done is we started with the cone and we've now got the net of a cone, the net of this solid. So this orange sector was the curved area of the cone and the circle below is the base of the cone. Now when we do this, if we look at the left hand image of the cone, we see that L is 4. That now translates on this orange sector to what looks like the radius of a circle, because we have a sector here of a circle. So L equal to 4 is now equal to the radius of a larger circle, and the angle that we get, theta, is pi over 2. And on the bottom circle, the radius remains 1. So the area of the circle, which is the smaller one at the bottom, using a formula pi r squared centimeter squared. Well, r for us is 1, meaning r squared is also 1. So the area of the smaller circle is pi centimeter squared. Next thing we need to do is find the area of the orange sector. Now we saw that when we measure theta in radians in a sector, the area of a sector is equal to a half L squared theta. So for us we get a half times L, which in our case is or R, it's often written as, for us is the radius of the larger circle that the sector is in. So for us we have 4, so we have a half times 4 squared times theta, which is for us pi over 2. That gives us 16 pi over 4, which is equal to 4 pi centimeters squared. Now the area of the cone as a whole will be equal to the sum of the parts of the net of the cone, which we found was the area of the circle plus the area of the sector. And that gives us pi plus 4 pi centimeters squared, which is in total 5 pi centimeters squared. So finding the surface area of solids using these nets is quite useful when the shapes are irregular. Now, there are formulae in the tables book which tell you how to calculate the surface area of certain objects, but it's important to be aware that these formulae in the tables book, they give you the formula for the curved surface area. So just be aware that if you're answering a question that asks you to find the surface area, make sure you know that you need the total surface area, like we found with the cone, which included the base, the circle at the bottom, or do you just need the curved surface area, which in our case above would have been 4 pi centimeters squared, or just the area of the curved part of the cone, not including the circle. So if we look at an example, we'll look at the surface area of a cylinder. So again, we're going to find if you wanted to find the total surface area, you would need to add the area of the two circular faces and the area of the curved surface, which is the cylinder part. The net of the cylinder shows that the curved surface area is actually a rectangle when it's stretched out. So the rectangle has sides of length h and 2 pi r, and the circles have radius length r. So the surface area, the total surface area of a cylinder, is equal to 2 pi r squared. So we have pi r squared is the area of each of the circles, and we have 2 of these circles, so 2 times pi r squared plus 2 pi r h, which is the area of the blue rectangle. So in total, the total area of the cylinder, both curved and not curved, is 2 pi r times r plus h. And we'll look at one last example, is the surface area of a sphere. Now to find this, the curved surface area is the same as the total surface area. So to do this, we can use the formula in the tables book. So the surface area of a sphere is 4 pi r squared. If we look at an example, if the radius of the sphere is 3 centimeters, then the surface area of the sphere is 4 pi times 3 all squared, which is equal to 36 pi centimeters squared.